This is the EdExcel AS Level Maths Paper 1, covering the Pure Maths section, and it's from the 2021 series. Question number 1. In this question, you should show all stages of your working. Solutions relying on calculator technology are not acceptable. Using algebra, we have to solve the inequality x squared minus x being greater than 20. First of all, let's rearrange so one of the sides is 0. We can do this by subtracting 20 from both sides. If we do so, we have x squared minus x minus 20 is greater than 0. We can find the critical values by replacing the inequality symbol with an equals symbol. If we do so, x squared minus x minus 20 is equal to 0. Let's now solve this quadratic. We can factorize. We require two numbers which multiply to give minus 20, add to give minus 1. Of course, we've got minus 5 and 4. So when we come to factorize as the product of two brackets, x squared minus x minus 20, we have x minus 5 multiplied by x plus 4, and this, of course, is equal to 0. And if we solve to find our critical values, if x minus 5 is equal to 0, x is equal to 5, and if x plus 4 is equal to 0, x is equal to minus 4. We have found our critical values. Let's draw a sketch of the graph y equals x squared minus x minus 20, but ignoring the y-axis. We have a sketch of y equals x squared minus x minus 20. Of course, we have completely ignored the y-axis. If we add on our critical values, we've got minus 4 and 5. Now, we are looking for where the graph is greater than 0. And it's greater than 0 here or here. So when we come to state the solutions to this inequality, we have x, which is less than minus 4, or we have x, which is greater than 5. And if we express this in set notation, we have x belonging to a set of real numbers. X is less than minus 4, or we have x belonging to a set of real numbers. X is greater than 5. Here is the solution to the inequality in set notation. Question number 2. In this question, you should show all stages of your working. Solutions relying on calculator technology are not acceptable. Given 9 to the power of x minus 1 over 3 to the power of y plus 2 is equal to 81, we have to express y in terms of x, writing your answer in simplest form. What we can do is rewrite both the left hand side and the right hand side, so we have a base of 3. That will make it easier for us to compare powers. And of course, in this question we can make use of the laws of indices. 9 is the same as 3 squared. So we have 3 squared to the power of x minus 1 divided by 3 to the power of y plus 2. This is equal to 81, and 81 is the same as 3 to the power of 4. We have a base to a power to another power, so we multiply the powers. We have 3 to the power of 2 lots of x minus 1 divided by 3 to the power of y plus 2. This is equal to 3 to the power of 4. If we expand the brackets on the top, we have 3 to the power of 2x minus 2. On the bottom, 3 to the power of y plus 2. This is all equal to 3 to the power of 4. When we have the same base and we are dividing, we subtract the powers. So on the left hand side we have 3 to the power of 2x minus 2 minus y plus 2. And this is equal to 3 to the power of 4. On both the left hand side and the right hand side we have the same bases, so we can now compare powers. If we compare the powers on the left hand side, we've got 2x minus 2 minus y plus 2. On the right hand side we've got 4. Let's rearrange so we have y in terms of x. We have 2x minus y, and then we have minus 2 minus another 2, so that's minus 4, and this is equal to 4. If we add 4 to both sides, we have 2x minus y equals 8, and so therefore y is equal to 2x minus 8. We have expressed y in terms of x. Question number 3. We have to find the integral of 3x to the 4 minus 4 over 2x to the power of 3 with respect to x, writing the answer in simplest form. Let's begin by copying out this integral. We have 3x to the 4 minus 4 divided by 2x cubed, and we are integrating this with respect to x. If we split this fraction up, we can split it up as 3x to the 4 divided by 2x cubed minus 4 over 2x cubed. We will then integrate this with respect to x. Three x to the 4 divided by 2x cubed. Well, 3 over 2 can be left as it is. And then x to the 4 divided by x cubed. That's just x. And then we subtract 4 divided by 2, which is 2. And then, of course, here we've got 2 over x cubed, which is the same as 2x to the power of minus 3. We will integrate this result with respect to x. When we integrate, we add 1 to the power and divide by the new power. So what we end up with over here is 3 over 4 x squared, and then if I add 1 to the power, I get minus 2, and then if I do minus 2 divided by minus 2, we end up with plus 1. So we've got x to the power of minus 2. And then we add on a constant of integration, c. Question number 4. In this question, the unit vectors I and j are due east and due north respectively. A stone slides horizontally across ice. Initially, the stone is at the point A, minus 24i minus 10j meters relative to a fixed point O. After 4 seconds, the stone is at the point B, 12i plus 5j meters relative to the fixed point O. The motion of the stone is modelled as that of a particle moving in a straight line at constant speed. Using the model for part A, we have to prove that the stone passes through O. Well, we know so far OA is equal to minus 24i minus 10j. And we know that OB is equal to 12i plus 5j. We want to show that the stone passes through the origin. So what we want to show is AOB is a straight line. So if we know that OA is minus 24i minus 10j, we can therefore conclude AO is equal to the negative of this 24i plus 10j. And in order to show that AOB is a straight line, we need to show that AO is a multiple of AB. Well, what you can see from here then is AO is equal to 2 lots of OB. Of course, 24i plus 10j is equal to 2 lots of 12i plus 5j. And so what we can conclude then, the particle passes through the point O. And now for part B, we have to calculate the speed of the stone. Well, to do this, we need to find the vector AB, and that will tell us the distance. And then we can find the speed by using speed equals distance divided by time. So, we have on this diagram the points A and B, and we've got this origin over here. What we can do is find the vector AB. It starts at A, it finishes at B, so we can find out what the vector AB is. The vector AB, well, from minus 24 to 12, we go 36 in the I direction, and from minus 10 to 5, we go 15 in the J direction. So what we have found here then is the vector AB. So what we now need to do, given that we found the vector AB, we can therefore conclude that the distance the particle travels will be given by the magnitude of AB. This is equal to 36 squared plus 15 squared square rooted. So the distance, we've got 36 squared plus 15 squared square rooted, which is 39. So we've got 39 meters for the distance, and therefore the speed is equal to the distance, 39 meters, over the time, 4 seconds. The speed is equal to 9.75 meters per second. Question number 5. We have figure 1, which shows part of the curve with the equation y equals 3x squared minus 2, and we've got the point P with coordinates 2, 10, and this lies on the curve. For part A, we have to find the gradient of the tangent to the curve at the point P. For part A, if we were to find the gradient of the tangent to the curve at P, we would have to, first of all, find out what dy over dx is, which tells us the gradient function of the tangent. Dy over dx, that's equal to 6x, and at the point P with coordinates 2, 10, dy over dx is equal to 6 lots of 2, which is 12. So this 12 over here represents the gradient of the tangent at the point P. And now for part B, the point Q with x coordinate 2 plus h also lies on the curve. We have to find the gradient of the line PQ, giving an answer in terms of h in its simplest form. Well, we've got this point P over here, and then we've got the point Q with coordinates 2 plus h for the x coordinate, and for the y coordinate we replace the x with 2 plus h. So for the y coordinate we would have 3 lots of 2 plus h all squared minus 2. And so what we can do now is find the gradient of PQ. So if we were to find the gradient of PQ, we can do that by considering the change in y over the change in x. The gradient of PQ then, we have the change in y, well we've got 3 lots of 2 plus h all squared minus 2, take away 10. So we've got 3 lots of 2 plus h all squared minus 2, and then we subtract off 10, so that's the change in y. And then the change in x, we have 2 plus h minus 2. And if we were to work this out, we've got 3 lots of 4 plus 2h plus h squared minus 12 divided by h. 12 plus 6h plus 3h squared. Rather, here we have 4, so here we have 12. So we've got 12 plus 12h plus 3h squared minus 12 on the top. And on the bottom, we've got h. So we can conclude then what we end up with as the gradient function. We've got 12h plus 3h squared divided by h, which is just 12 plus 3h. So we have 12 plus 3h. And now for part C of the question, explain briefly the relationship between part B and the answer to part A. Well, as h gets smaller and smaller, in other words, as h tends towards 0, then 12 plus 3h would tend towards 12. Of course, 3h would tend towards 0. So the gradient of the chord tends to the gradient of the tangent to the curve. Question number 6. In this question, you should show all stages of your working. Solutions relying on calculator technology are not acceptable. For part A, we have to use algebra to find all the solutions to the equation 3x cubed minus 17x squared minus 6x equals 0. The first thing we will do is factorize out an x from each term. So we have x lots of 3x squared minus 17x minus 6 equals 0. And if we attempt to factorize the quadratic, we have 3x plus 1 multiplied by x minus 6. And then of course we multiply this by x. And the result of all of this is equal to 0. So either x is equal to 0 if 3x plus 1 is 0, x is equal to minus 1/3, and if x minus 6 is 0, x is equal to 6. We have found the solutions to the equation 3x cubed minus 17x minus 6x equals 0. And then for part B, hence find all the real solutions of 3 lots of y minus 2 all to the power of 6 minus 17 lots of y minus 2 to the power of 4 minus 6 lots of y minus 2 all squared equals 0. Perhaps if we rewrite the equation, well, let's begin by copying out the equation. We've got 3 lots of y minus 2 to the power of 6 minus 17 lots of y minus 2 to the power of 4 minus 6 lots of y minus 2 squared. This is all equal to 0. And if we use the laws of indices, you can see we've got 3 lots of y minus 2 squared to the power of 3 minus 17 lots of y minus 2 squared minus 6 lots of y minus 2 squared, and this is all equal to 0. What we have done here is rewrite everything in terms of y minus 2 all squared. The reason for this is because if we compare with what we have in our original equation, you can see then x is equal to y minus 2 all squared. So, comparing with part A, we can see x is equal to y minus 2 all squared. So, we've got y minus 2 all squared equaling either 0, minus 1/3, or 6. But of course here, y minus 2 all squared cannot equal minus 1/3. We won't get any real solutions. So, if we get rid of this, y minus 2 all squared can either equal 0 or 6. Let's just make a note why that's y minus 2 all squared equals minus 1/3 has no real solutions. Of course, we cannot square root a negative number. And so, we have y minus 2 all squared equals 0, from which we can see y is equal to 2, or we've got y minus 2 all squared equals 6, and if you square root and then add 2, we can conclude y is equal to 2 plus minus square root 6. And therefore, if we state the solutions, we've got y equals 2 and y equals 2 plus minus square root 6. These are our only real solutions. Question number 7. A parallelogram PQRS has area 50 cm squared. We're given that PQ has length 14 cm and QR has length 7 cm and the angle SPQ is obtuse. What we have to do for part A is find the angle SPQ in degrees to 2 decimal places. Here is a diagram of the parallelogram. We are given that PQ is 14 centimeters. We are also given that QR has length 7 centimeters. We are given SPQ is obtuse, and we have to find this angle here. Well, how would we go about finding the area of a parallelogram? Well, the area of a parallelogram is twice the area of a triangle. Now, to begin with, we can find out this angle over here, the angle PQR. We'll call it theta for now. How can we do that? Well, to find out the area of one of these triangles, that's 1/2 times by 7 times by 14 times by the sine of theta. And then we multiply this by 2 because we've got twice these triangles, and this area is equal to 50. So, sine theta, that's equal to 50 over 7 times 14, which is 25 over 49. From which we can conclude theta is equal to the inverse sine of this, which is 30.67, etc. And therefore the angle SPQ, because it's obtuse, and here we've got co-interior angles, we've got 180 minus this 30.67, etc. So we've got 180 minus this, which is 149.32 degrees, given to 2 decimal places. And now for part B, we have to find the length of the diagonal SQ. Give your answers to 1 decimal place. Well, we know that this length here is also 7. We know the angle here is 100 and, let's just underline it. We've got 149.32 for this angle here. So this angle is 149.32 degrees, given to 2 decimal places. And what we need to find is this length SQ, and we can do that using the cosine rule. So for part B of the question, if we use the cosine rule, SQ squared equals 14 squared plus 7 squared minus 2 times by 14 times by 7 times by the cosine of 149.3, etc. So if we work out what SQ is, we have 14 squared plus 7 squared minus 2 times 14 times 7 times the cosine of this, which is 413.5, etc. And therefore, SQ, that's equal to the square root of this, which is 20.3 centimeters, given to 1 decimal place. So if we add this to our diagram, we've got 20.3. Question number 8. G of x is equal to 2 plus ax to the power of 8, where a is a constant, and given that one of the terms in the binomial expansion of g of x is 3402x to the 5, we have to find the value of a. Well, it would make sense for us to find the value of a by working out the coefficient of x to the 5. If we go to the formula book, we can find out the coefficient of x to the 5 using the results we see here. So the results here will allow us to find out the coefficient of x to the 5. So the coefficient of x to the 5, that's equal to 8 choose 5 multiplied by 2 to the power of 3 multiplied by a to the power of 5. So if we work this out, 8 choose 5 multiplied by 2 cubed, we get 448 a to the 5 as the coefficient of x to the 5. And this over here, the coefficient of x to the 5, is equal to 448 a to the 5. And so setting them equal to each other, we've got 448 a to the power of 5 equals 3,400 and 2, we need to find out what a is. So a to the power of 5 is equal to 3402 divided by 448, which is 243 over 25, or rather over 32. A is the fifth root of this, which is 3 over 2. So a is equal to 3 over 2. And now for part B, using this value of a, what we have to do is find the constant term in the expansion of 1 plus 1 over x to the 4 multiplied by 2 plus ax to the power of 8. So, for part B, we have 1 plus 1 over x to the 4, so we've got 1 plus 1 over x to the 4 multiplied by 2 plus a to the, well, we've got 2 plus 3x over 2 to the power of 8. And what we have to do is somehow find out the constant term. Now, what we'll do is we'll write out a couple of terms of the expansion of 2 plus 3x over 2 to the power of 8 in a certain order. We've got 1 plus 1 over x to the power of 4, and then what we will do is multiply this by the following. Well, first term, that's going to be 8 choose 0, and then we've got 2 to the power of 8 multiplied by 3x over 2 to the power of 0. And then for the next term, 8 choose 1, 2 to the power of 7, 3x over 2 to the power of 1. Now, the question is, when do we exactly stop? We could write out the full expansion, but what we need to do is find the constant term. Now here, the 1 times by the result here will give a constant term, but then we've got this 1 over x to the 4, and if I multiply that by something involving an x to the 4 in the numerator, those will cancel out to give a constant term. So we could continue with this, but as soon as we're at 8 choose 4 times by 2 to the power of 4 multiplied by 3x over 2 to the power of 4, those terms here will give an x to the 4 term. Let's just move all this. So we've got various different terms. So what multiplies to give a constant term? So let's just write this down. The constant term, we've got 1 multiplied by the result here. So we've got 1 multiplied by 8 choose 0, 2 to the power of 8 multiplied by 3x over 2 to the power of 0, and what else gives a constant term will be the 1 over x to the 4 multiplied by this here. So we've got 1 over x to the 4 multiplied by 8 choose 4, 2 to the 4 multiplied by 3x over 2 to the power of 4. Why is that the case? Well, let's just continue working all of this out. We've got 1 multiplied by 1 multiplied by 2 to the power of 8, which is 256, multiplied by 1, so that's this result here. And what we also have is 1 over x to the 4 multiplied by, well, let's just write this down. We've got 1 over x to the 4 multiplied by 8 choose 4, which is 70, multiplied by 2 to the power of 4, so we've got 2 to the power of 4, which is 16, and then we've multiplied this by 3x over 2 all to the power of 4, so here we've got 1.5 power of 4, which is 81 over 16. So we multiply this by 81 over 16, or the 81 x to the 4 over 16. So that is these terms multiplied together. And happily for us, this and this cancel out. So the constant term then is equal to 256 plus 70 times 16 multiplied by 81 over 16. It turns out we get 5,926 as the constant term. Question number 9. We have to find the value of the constant k, where k is in between 0 and 9, such that the integral of 6 over square root x with respect to x between k and 9 is equal to 20. Well, let's rewrite this integral. We've got the integral from k to 9 of 6x to the power of minus 1/2. And we're integrating this with respect to x. So add 1 to the power, we get x to the power of 1/2. And if I divide by the new power, 6 divided by 1/2 is 12. So what we need to work out is 12x to the power of 1/2 evaluated between k and 9. So we have 12 lots of 9 to the power of 1/2 minus 12k to the power of 1/2, and if we tidy this up even further, 3 times 12 is 36. We've got 36 minus 12k to the power of 1/2. And if we set this result equal to 20, we've got 36 minus 12k to the power of 1/2. This is equal to 20. So if we rearrange, we've got 12 k to the power of 1/2 equals 16. K to the power of 1/2 is equal to 16 divided by 12, which is 4/3. And if we square both sides, k then is equal to 16/9. So we have k equals 16/9. Question number 10. A student is investigating the following statement about natural numbers. N cubed minus n is a multiple of 4. We have to prove using algebra that the statement is always true for odd numbers. So the first thing we will do is state the form of an odd number. We know odd numbers are of the form 2x plus 1. So if we let n equal 2x plus 1, then n cubed minus n will equal n cubed, so we've got 2x plus 1 cubed minus 2x plus 1. And of course here, x is an integer. So if we expand this out, well, here we need to use the binomial. So expanding, we've got 1, lots of 2x to the power of 3 multiplied by 1 to the 0, plus 3 lots of 2x squared lots of 1 to the 1, plus 3 lots of 2x to the 1 times by 1 squared, plus 1 lots of 2x to the 0, 1 cubed, and then we subtract off 2x, and then we subtract the 1 as well. Well, the term here would cancel with the term here. So we've got 8x cubed plus, well, we've got 12x squared plus 6x, and then we've got, rather here, there's only the minus 1 which cancels, so here we've got 2x minus 1, and rather this cancelled out. So then we subtract off 2x. So we have 8x cubed plus 12x squared plus 4x. And if I take out a 4 as a common factor, we've got 4 lots of 2x cubed plus 3x squared plus 1. So what we have here then is 4 lots of an integer, because x is an integer, 2x cubed plus 3x squared plus 1 is also an integer. And this result here is a multiple of 4. And now for part B, we have to use a counterexample to show that the statement is not always true. Well, we can use any integer. For example, what would happen when n is equal to 2? Well, we would have 2 cubed minus 2, which is equal to 6. And 6 is not a multiple of 4. So therefore, this entire statement is sometimes true. Question number 11. The owners of a nature reserve decided to increase the area of the reserve covered by trees. Tree planting started on the 1st of January 2005. The area of the nature reserve covered by trees, 8 kilometers squared, is modelled by the equation A equals 80 minus 45 e to the power of ct, where c is a constant and t is the number of years after the 1st of January 2005. Using the model, we have to find the area of the nature reserve that was covered by trees just before tree planting started for part A. Well, just before tree planting started, that of course is when t equals 0. So when t is equal to 0, A is equal to 80 minus 45 e to the power of 0. E to the power of 0 is 1. 80 take away 45 is 35. So therefore, we have 35 meters squared. For part B, on the 1st of January 2019, an area of 60 kilometers of the nature reserve was covered by trees. Use this information to find a complete equation for the model. Give a value of c to 3 significant figures. Well, A this time is equal to 60 and t is equal to 14. The reason t is equal to 14, from 2005 to 2019, this over here is 14 years. And knowing that A is equal to 60, we have 60 equals 80 minus 45 e to the power of 14c. And what we need to do is find out what c is. If we rearrange, 45 e to the power of 14c is equal to 20. So 14c, rather if we divide through by 45 to begin with, e to the power of 14c is equal to 4/9. So 14c is equal to the natural log of 4/9, from which we can conclude c is equal to 1/14 times by the natural log of 4/9. And if we work out the decimal equivalent of this, 1/14 multiplied by the natural log of 4/9, you'd find this to equal minus 0.0579, etc. And giving the value of c to 3 significant figures, the equation of the model is given by A equals 80 minus 45 e to the power of minus 0.0579 t to 3 significant figures. And now for part C of the question. On the 1st of January 2020, the owners of the nature reserve announced a long-term plan to have 100 kilometers squared of the nature reserve covered by trees. We have to state a reason why the model is not appropriate for this plan. Well, what we'll do to begin with for part C is draw a sketch of A against T. Here is a sketch of the graph of A against T. We have an asymptote, of course, a horizontal asymptote at A equals 80. We've got the initial area 35, we calculated that before. And so what we can conclude then is the maximum area covered by trees only is 80 kilometers squared. Question number 12. In this question, you should show all stages of your working. Solutions relying entirely on calculated technology are not acceptable. For the first part, we have to solve in between 0 and 450 the equation 5 cos squared theta equals 6 sin theta, giving it answers to one decimal place. We begin with 5 cos squared theta equals 6 sin theta. If we replace cos squared with 1 minus sin squared, we would have 5 lots of 1 minus sin squared theta equals 6 sin theta. And if we expand the brackets on the left hand side, we've got 5 minus 5 sin squared theta equaling 6 sin theta. So, rearranging so one side is equal to 0, we have 5 sin squared theta plus 6 sin theta minus 5 equals 0. We now need to solve this. So if we find out what sin theta is, we can use our equation solver on the calculator. We've got 5 sin squared plus 6 sin minus 5 equals 0. We get a value of 0.566, etc. And the other value, that's equal to minus 1.76, etc. So we've got sin theta equaling minus 1.766, etc. Now, can this work? Can sin theta equal minus 1.766, etc.? Well, no, it can't, because sin is in between minus 1 and 1. So sin theta does not equal minus 1.766, etc. Our only value is this here. Let's store this into our calculator. And so to find out what theta is, to one decimal place then, we have the inverse sine of this so let's just we have the inverse sine of that value, which is 34.5 degrees. We add on 360 because if we remember for our domain, the value of theta is in between 0 and 450. So here we get a value of 394.5 degrees. and if I just take away 360, we can do 180 minus this, which is 145.5 degrees. We have given all our solutions to one decimal place. Now for the next part of the question. A student's attempt to solve the equation, solve for x being in between minus 90 and 90, the equation 3 tan x minus 5 sin x equals 0 is set out below. We have to identify two errors or omissions made by the student, giving a brief explanation of each. Well, if we take a look at the first line, we've got 3 tan x minus 5 sin x equals 0. They've replaced the tan x with sin x over cos x, leaving us with 3 sin x over cos x minus 5 sin x equals 0. They have then multiplied through by cos x, leaving us with 3 sin x minus 5 sin x cos x equals 0, which is correct. And then they've just divided through by sin x. They've cancelled sin x and therefore missed a solution. So let's just write that down. So on line 4, they cancel by sin x and hence miss the solution sin x equals 0, which implies x equals 0. Now, with the 3 minus 5 cos x equaling 0, they rearrange successfully to get cos x equals 3 over 5. So if I do the inverse cos of 3 over 5, we get 53.1, which is what they got. But if we take a look at the domain, minus 19 to 90, we also have a solution of minus 53.1, and that's because of the symmetry of the graph. So let's write down the second mistake. They do not find all the solutions of cos x equals 3 over 5 in the domain minus 90 to 90, and so they missed the solution x equals minus 53.1. And now for part C. The first four positive solutions in order of size of the equation cos of 5 alpha plus 40 degrees equals 3/5 are alpha 1, alpha 2, alpha 3 and alpha 4. We have to find to the nearest degree the value of alpha 4. So for part B, we have cos of 5 alpha plus 40 equals 3 over 5. 5 alpha plus 40, we would expect to get multiple solutions. Here's the first solution, 53.13, etc. The next solution, well, let's just store this into A. The next solution will be 360 minus this, which is 306.86, etc. Let's store this into B. The next solution will be this value, the 53.1, etc. plus 360. So we have A plus 360, which is 413.13, etc. Store this into C. And for the final solution, we've got the value of B plus 360, which is 666.86, etc. We will store this into D. And then if we divide each of those, well, if we subtract 40 and then divide each of those by 5, you will find alpha to equal, well, first of all, we've got A minus 40 over 5. The first angle is 2.62, etc. The next one we have 53.37, etc. The next one, we have 74.62, etc. And the final one, we get 125.37, etc. We have here alpha 1, alpha 2, alpha 3, and alpha 4. And so therefore we can conclude alpha 4 is equal to 125 degrees to the nearest degree. Question number 13. The resting heart rate h of a mammal measured in beats per minute is modelled by the equation h equals pm to the power of q, where p and q are constants and m is the mass of the mammal measured in kilograms. Figure 2, which is what we see here, illustrates the linear relationship between log base 10 of h and log base 10 of m. The line meets the vertical log base 10 of h axis at 2.25 and it's got a gradient of minus 0.235. For part A, we have to find three significant figures, the values of p and q. Think of this to be in the form y equals mx plus c. Instead of us having an x, instead we've got log base 10 of m. And instead of us having a y, we've got log base 10 of h. Now normally, we can write y equals minus 0.235, which is the gradient, times by x plus 2.25. But instead of us having those variables of x and y, we've got log base 10 of m and log base 10 of h instead. So what we can do for part A then is replace the y with log base 10 of h, and we can replace the x with log base 10 of m. So if we do that, we've got log base 10 of h equals 2.25 minus 0.235 times log base 10 of m. So if we anti-log both sides, we have 10, we've got h equals 10 to the power of 2.25 minus 0.235 times log base 10 of m. And if we use the power law of logs, we can rewrite h as 10 to the power of 2.25 plus log base 10 of m to the power of minus 0.235. And so, because we've got a 10 to the power of two results which are added, we can use the law of indices. A to the power of m plus n is equal to a to the power of m times a to the power of n. When we've got the same base and we're multiplying, we add the powers. So h then is equal to 10 to the power of 2.25 multiplied by 10 to the power of log base 10 of m to the power of minus 0.235. Now 10 to the power of log base 10, that's just going to, of something, is just going to be m. So let's just write this law down. If we've got x to the power of log base x of y, say, this is just equal to y. So if we use that idea, we can see then h is equal to 10 to the power of 2.25 multiplied by m to the power of minus 0.235. So therefore, p is equal to 10 to the power of 2.25, which if we work this out, we get 178 to 3 significant figures. So this is the value of p. And then the value of q that's equal to minus 0.235. Of course, this is given to 3 significant figures. So we have our value for p. We've got the value of q. So now with that, a particular mammal has a mass of 5 kilograms and resting heart rate of 119 beats per minute. We have to comment on the suitability of the model for this mammal. Well, this time we are given that the mass is 5 kilograms. So with our model, we can replace m with 5. So h then is equal to 10 to the power of 2.25 multiplied by 5, which is the mass, to the power of minus 0.235, where of course this is the value of p, and this is the value of q. So if we find out what h is, we've got 10 to the power of 2.25 multiplied by 5 to the power of minus 0.235. We get 121.8, etc. And if we look at the units, we have beats per minute. So we have 121.8, etc. beats per minute. And if we take a look at what it actually is, well, it's actually 119 beats per minute. So let's just write this down. It is actually 119 beats per minute. These values are close. So what can we say then? We can say then that it's reasonably accurate to 2 significant figures if I round both the h value here and the 119 to 2 significant figures. We get 120. Beats per minute. That is of course to 2 significant figures, and so the model is suitable. Now for part C of the question, with reference to the model, we have to interpret the value of the constant p. Quite simply, p is the resting heart rate in beats per minute of a mammal with mass of 1 kilogram. Question number 14. A curve C has equation y equals f of x, where f of x is equal to minus 3x squared plus 12x plus 8. We have to write f of x in the form a lots of x plus b all squared plus c, where a, b and c are constants to be found. So, for part A, we begin with minus 3x squared plus 12x plus 8. And we need to write this in the form given to us here. The form given to us over here suggests we need to complete the square. So if I factorize out the coefficient of x from the first two terms, the coefficient of x squared from the first term and the second term, we have minus 3 on the outside, and inside this big bracket would have x squared minus 4x, close big bracket, and then we've got the plus 8. So if we complete the square of this big bracket, we've got minus 3 on the outside, and then here we would have x minus 2, half of the 4 is 2. And then we square this and we subtract off the square of 2, which is 4. And then we've got the plus 8. So we've got minus 3 lots of x minus 2 all squared. Minus 3 times minus 4 is plus 12. And then we've got the plus 8. So if we tidy all of this up, we've got minus 3 lots of x minus 2 all squared plus 20, from which we can conclude f of x is equal to minus 3 lots of x minus 2 all squared plus 20. Part B of the question. The curve C has a maximum turning point at M, and we have to find the coordinates of M. Well, the turning point, that will be negative b, c. So the turning point would have coordinates negative b, c. So we've got negative, negative 2, so that's 20. Rather, that's 2, and then for the y coordinate of the turning point, we've got 20. So M has coordinates to 20. And now for part C of the question. Figure 3 shows a sketch of the curve C, that's what we see here, and the line L passes through M and is parallel to the x-axis. The region R, shown shaded in figure 2, is bounded by C, L and the y-axis. We have to use algebraic integration to find the exact area of R. Well, L would have equation y equals 20. It's parallel to the x-axis and it's a tangent to the curve. So L has equation y equals 20. Let's find out the area of the rectangle. Now, what do we mean by that? The area of the rectangle is the area everywhere here between 0 and 2. Remember, the coordinates of M is 2, 20. So we've got 2 across, 20 up. We can find out the area of the rectangle. So the area of the rectangle is 2 times by 20, which is 40 units squared. We can now find the area under the curve between 0 and 2. So what we can do now is find the area under the curve between 0 and 2. So the area under the curve we can find using integration. We can integrate between 0 and 2 minus 3x squared plus 12x plus 8. So if we integrate this, of course we add 1 to the power, divide by the new power. We've got minus x cubed plus 6x squared plus 8x, and this will be evaluated between 0 and 2. So we've got minus 2 cubed plus 6 lots of 2 squared plus 8 lots of 2 for the upper limit. For the lower limit, we'd have 0, another 0, and then another 0. So it turns out here we get 32 units squared. And so, therefore, the area of R is equal to 40 minus 32. It turns out the area of R is equal to 8 units squared. Question 15. Figure 4 shows a sketch of a circle C with centre N with coordinates 7, 4 and the line L with equation y equals 1/3 x is a tangent to C at the point P. For part A we have to find the equation of the line NP in the form y equals mx plus c, where m and c are constants. Well, for part A, we begin with the line L. This has equation y equals 1/3 x. And so what we can see here then is the gradient is equal to 1/3. And so the gradient of the line Pn will be the negative reciprocal of this. So the gradient of Pn is the negative reciprocal of 1/3, which is minus 3. And so using y minus y1 equals m lots of x minus x1, we have y minus, well, it passes through the point 7, 4. So we've got y minus 4 equals minus 3 lots of x minus 7, from which we can conclude the line Pn as equation y equals, well, here we've got minus 3x, then we've got minus 21 plus 4. Rather, we've got plus 21 plus 4, which is 25. So we'll call this equation 1. We'll call this equation 2. And now for part B of the question, we have to find an equation for C. Well, before we do anything else, we need to find out the length of NP, which is the radius. Now we know that N has coordinates 7, 4, and we know that P has coordinates. Well, we can find out the coordinates of P by solving this equation with this equation simultaneously. So if I do that, we've got this line over here, which is the line NP, and from that we can find out the point P by solving NP simultaneously with L. In other words, we will solve equation 1 and 2 simultaneously. And we can do that by setting them equal to each other. So we've got 1/3 x equals minus 3x plus 25. So we've got 10 over 3x equals 25. So x is equal to 15 over 2. And if I multiply this by a third, the corresponding y coordinate is equal to 5 over 2. So we've got the coordinates of P, 15 over 2, and for the y coordinate we've got 5/2. So we can find out the length of RP, which is of course just the radius. So this is the radius. So therefore, R is equal to, if we use the length formula, we've got 15/2 minus 7 squared plus 4 minus 5/2 squared square rooted. So if we find out what the radius is, we have the square root of 7.5 minus 7 squared plus 4 minus 2.5 squared all square rooted, which is root 10/2. So therefore, the radius is root 10/2, and if I square this, it turns out for the equation of C, we've got x minus 7 all squared plus y minus 4 all squared equals 5/2. And now for part C, the line with equation y equals 1/3 x plus k, where k is a non-zero constant, is also a tangent to C. We have to find the value of the constant k. Now, if we go back to our diagram, let's just add on this tangent line. We'll do it here. Here, we've got our line. We'll call it L2. L2 intersects C over here at some point Q. And what we can do is find out what the coordinates of Q are. And we can do this using vectors. So if we were to use vectors, let's just draw a quick diagram to illustrate what we need to do for part C. Here is our circle. We've got Q, N, and P. Now, what we can do is determine how we go from N to P. And then we can use that information to find out how we go from Q to N. Well, in the x direction, to go from 7 to 15/2, we add on a half. So we add on 0.5 in the x direction. And to go from 4 to 5/2, we subtract 3/2. So if we scroll down here, we go down by minus 1.5, 3/2 in other words. So we have to do the same thing here. We add on 0.5, and then here we would take away 1.5. So currently we've got the coordinates of N being 7, 4. If we go back to the question, we've got 7, 4. Here we've got 7.5, 2.5. So if we work backwards, we take away 0.5 from 7. So here we get 6.5. And then we add on 1.5 to 4 to get 5.5. So we've used vectors to essentially work backwards. So let's just move this over here. So if I add on those coordinates, we'll leave them as fractions for now. we've got 13 over 2. And then we've got 11 over 2. Now, if we substitute this point into y equals a third x plus k, we can find the value of k. So, we know y equals 1/3 x plus k. And so, if we use the point Q with coordinates 13 over 2 and 11 over 2, we've got 11 over 2 for the y. This is equal to 1/3 lots of x. So perhaps if we put a bracket here, x is 13 over 2, and then we add on k, from which we can find out what k is. We've got 11 over 2, take away 1/3 lots of 13 over 2, which is 10 over 3. And so therefore, y is equal to 1/3 x plus 10 over 3. That's the equation of the line, which is also a tangent to C. Question 16. The curve C has equation y equals f of x, where f of x is equal to ax cubed plus 15x squared minus 39x plus b. A and b are constants. We're given that the point 2, 10 lies on C, and the gradient of the curve at 2, 10 is minus 3. We have to show the value of a is minus 2 and find the value of b. So for part A, we begin with f of x, which is equal to ax cubed plus 15x squared minus 39x plus b. If we differentiate, the reason we have to differentiate is because we've been given information about a gradient. We would get 3ax squared plus 30x minus 39. Now, we're given that f of 2 is 10. So if we use this information and substitute it into here, we've got ax cubed, so we've got a lots of 2 cubed plus 15 lots of 2 squared minus 39 lots of 2 plus b. This is equal to 10. We have 8a plus 60 minus, well, here we've got minus 78 plus b. This is all equal to 10. And so therefore, 8a plus b is equal to 28. We'll call this equation 1. And we've also been given information about the gradient. The gradient is equal to minus 3 at the point x equals 2. So f dash of 2 is equal to minus 3. So we've got 3a lots of 2 squared plus 30 lots of 2 minus 39. This is equal to minus 3. 12a plus 60 minus 39 equals minus 3. 12a equals minus 24. A is equal to minus 2. We'll call this 3. Just move this over here. And now if we substitute 3, let's call this 2. If we now substitute 2 into 1, we've got 8a, so we've got 8 lots of minus 2 plus b. This is equal to 28. So we've got minus 16 plus b equals 28. And therefore, b is equal to 44. And knowing that a is equal to minus 2 and b is equal to 44, we can therefore conclude f of x is equal to minus 2x cubed plus 15x squared minus 39x plus 44. We can also conclude f dash of x is equal to minus 6x squared plus 30x minus 39. Now for part B of the question, hence show that C has no stationary points. Well, stationary points would suggest to us f dash of x is equal to 0. We want to show that f dash of x does not equal 0. How can we do this? Well, we can use the discriminant. For part B, if we use the discriminant b squared minus 4ac, we have b squared, so we've got 30 squared minus 4, lots of minus 6, lots of minus 39. We are questioning whether this is greater than 0, equal to 0, or less than 0. 30 squared minus 4 times minus 6 times minus 39, that's minus 36, which is less than 0. We can conclude then there's no real roots to f dash of x equaling 0. And because f dash of x does not equal 0, we can conclude from this f of x has no turning points. Now for part C of the question, we have to write f of x in the form x minus 4 lots of qx, where q of x is a quadratic expression to be found. Well, for part C, we know what f of x is, that's minus 2x cubed plus 15x squared minus 39x plus 44. This is equivalent to x minus 4 lots of some quadratic lambda x squared plus beta x plus gamma. Now if we compare coefficients, concentrating on the x cubes, we've got minus 2 equals minus 4 times lambda. Rather, here we've got minus 2 equals lambda. So lambda is equal to minus 2. If we compare the numbers, we've got 44, which is equal to minus 4 times gamma. So therefore gamma is equal to minus 11. And if we compare the x squareds, say, we've got 15 of them on the left hand side. And on the right hand side, we've got minus 4 times by lambda. And then we've got x times by beta x, so the coefficient of x squared is beta. Now we know what lambda is, that's minus 2. So we've got 15 equals minus 4 times minus 2 plus beta. 15 equals 8 plus beta. Beta is equal to 7. And knowing the values of lambda, beta and gamma, we can therefore conclude that minus 2x cubed plus 15x squared minus 39x plus 44 is equivalent to x minus 4 multiplied by lambda x squared, so we've got minus 2 x squared plus beta x, so here we've got 7x, plus gamma, which is minus 11. So f of x is equal to minus 2x squared plus 7x minus 11 multiplied by x minus 4. Now that we've done that, hence deduce the coordinates of the points of intersection of the curve with equation y equals f of 0.2x and the coordinate axis. Well, let's see where the curve would intersect the x and y axis. It intersects the y axis when f of 0, when we have x equals 0. So f of 0, if I replace the x's with zeros, f of 0 is equal to 44. And therefore one of the points is 0, 44. And if I solve the equation f of x equals 0, we've got x minus 4, lots of minus 2 x squared plus 7x minus 11 equals 0. So either x minus 4 is equal to 0, from which we can conclude x is equal to 4. And if I attempt to solve the quadratic, we've got minus 2 x squared plus 7x minus 11. We do not get real solutions. And we can therefore conclude x equals 4. X equals 4 is the only real solution. And so the point where it intersects the x-axis is 4, 0. So we can conclude then, if we have f of 0.2x, let's just write this down. F of 0.2x, 0.2 being the same as 1/5. F of 1/5 x, well, let's just write this out properly. If we go from f of x to f of 1/5 x, going from f of x to f of 1/5 x is a stretch scale factor 5 in the x direction. So we multiply each of these x coordinates 0 and 4 by 5, and therefore we have 0, 44, of course. 0 times 5 is 0. And we have 4 times by 5, which is 20. Nothing's happening in the y direction. So the 0, 44 is where f of 0.2x intersects the y-axis, and the 20, 0 is where f of 0.2x intersects the x-axis.